A decarboxylation reaction can occur when there is a carbonyl that is beta from a carboxylic acid. And what I mean by beta is that it is 2 carbons away from the carboxylic acid carbon. Okay, and typically we call position 1 as alpha and position 2 is called beta. And so you can see that we have our beta position carbonyl. So this carboxylic acid is going to perform the decarboxylation reaction and form CO2, or carbon dioxide. So what we're going to do is we're going to add heat, and this triangle here is depicting heat. And so I'm going to draw the remaining carbonyl. Okay, and so the carbonyl, this would be the alpha position, and this would be the beta that I drew on the other side of the reaction arrow. And plus, we get CO2. And so just to give you guys a better view of it, the carboxylic acid becomes CO2. Okay, I've given an example of a much more complicated system here. And so what you're going to do is you're just going to figure out if there is a carboxylic acid that has a beta position carbonyl or ketone. Okay, and so if I am looking at this carboxylic acid first, I look at where the carbonyl is, right here, and I notice that it is alpha. It is only 1 position away. Okay, so that's not going to work. We're going to need to find another carboxylic acid. Okay, and so if we look at this carboxylic acid, we'll see that it is 1, 2, 3 carbons away for that carbonyl. That doesn't work because 2 is the beta position and there is no carbonyl there, so that's not what's going to work. Okay, we have one more carbonyl to look at. It is this one, or carboxylic acid to look at, sorry, it is this one. Okay, and if we go ahead and look, we have 2 carbons away. This is the beta position, and so this carboxylic acid can decarboxylate and form CO2. So with a little heat, we would form this molecule plus CO2. And it is this part right here that forms the CO2.